Our next speaker is Mael Kimalin, and he'll talk about Baremetal isolation with OVN on the DPUs. Take it away.
Yes, good morning. So this talk will be a little bit different. It's more like from a consumer or like end user point of view. It's about how we took all the building blocks that have been discussed here to create a solution for managing the networking for Baremetal. So this work was done with Adrian and Tarek that couldn't be here today. So yeah, of course. Okay, so let's start with DPUs and what this is. So DPUs are basically a paradigm shift from like having the services that we use for like the infrastructures, the network, the security from the CPU itself to an embedded ARM cores that we have on the NIC. So we are basically moving from a place where we had like the networking that was taking some CPU on the x86 to running those services on the DPUs, on those ARM cores, offloading everything from the host. So this means that we can run OVS on the DPU, right, instead of running it on the host. And if we can run OVS, we can actually run OVN also there. And the key point with doing this shift is that this DPU is actually managed completely separately from the host. So this allows us basically to have a trust separation between what runs on the host and what runs on the DPU. So this means that we can actually manage the DPU separately via some OOB interface. We can provision the OS, we can configure it, we can basically do the whole setup independently from the host. So this means that we can give the host to a tenant, like as a Baremetal machine, while keeping some control on what's happening for this host, specifically on the networking side, in the DPU. So a data center admin could set up the DPU, set up OVN and everything there, and then just provide the host as a Baremetal to a tenant that can then install his OS, run whatever he wants there, right? Kubernetes or Slurm, or it really doesn't matter. And by running OVN in the DPU using OVS Docker in this case, we are able to basically isolate the traffic from the host completely transparently from the host point of view. So the host will not see that it's isolated in a virtual network. It will just look and feel like it's like a Baremetal host without anything special, while under the hood we are tunneling everything. So this is the idea of this work. We basically wanted to do this Baremetal isolation on the DPU. So the DPU being this separated trust domain, we basically created a Kubernetes cluster for all our DPUs and then deployed OVN on top of this. So right now it's just OVN, but in the future we're going to bring like OVN interconnect for scalability. We have project to add BGP EVPN integration, to have ECMP and all of this. In the current work, we have chained the OVN with a router that is based on OVS that we have in NVIDIA called HPN. But we could also add like firewalling or like anything needed there. And we basically isolate the host traffic at the PF level. And this is the critical part that from the point of view of the host, there is the PF or the VFs. The host can use it as it expects to, but under the hood, all the traffic is encapsulated. And in this work, we did a lot of optimization for the traffic bandwidth specifically. We wanted to really limit the number of hops and maximize the throughput by keeping everything local to the DPU as much as possible. So we took an approach that has a logical structure like OVN Kubernetes. And in addition, we basically created an API wrapper around the OVN interface via some CRDs in Kubernetes. So basically, we achieved some network isolation per tenant, like having the overlay transparently. And the key part here is that all of this work does not require any switch reconfiguration. That was like a bit of like the complex points with solution like in OpenStack with Ironic, where like you needed to reconfigure the switch if you wanted isolation for the networking. Now that we have the DPU and OVN in the picture, this switch configuration is static. If the host is like switching tenants or like needs to be reprovisioned and moved to a different virtual network, then everything can be done from a central point of view, just like modifying a couple of CRDs that will be translated into a set of OVN northbound reconfiguration, let's say, and translate actually in a change on the DPUs. Okay, so this is the structure that we put in place. Like you can see, very similar to what we have in OVN Kubernetes. The goal here being that, like, if the traffic coming from node 1 or node 2 that are on the left and right needs to leave to the external network, it would do it within the DPU itself. So the network router has specific policies to keep all the traffic local, while if going across DPU like node to node, the traffic would just get encapsulated and directly change between the DPUs. So we have a small demo of. Oh, sorry, I skipped a slide. We wrap basically those infrastructure pieces in specific concepts in our API. So let's start with the VPC itself. The VPC basically represents the core infrastructure, like here, the logical switch that connects all the network routers and the gateway routers. And then the virtual network is like representing the set of network router and network switches that basically implement this virtual network. And then for the gateway router and gateway switch, it's a variation of the virtual network that is specifically for external, like an external virtual network. And then the last missing piece is the service interface. So it's basically the interface to the host. Those can be PFs, VFs as needed. The only catch here is the VFs are actually created from the host. So it means that whenever you want to add the virtual functions to the OVN setup, you will actually pre-configure it in the Kubernetes API. But this will only get actually applied once the host creates the interface and everything gets reconciled again. And at that point, the representative of the VF will be added to BRINT, and then the traffic will be able to flow. Okay. Is there a way to put it full screen? Okay, okay, I hope this is readable. But let me present a bit what this is about. So here you can see the Kubernetes API that defines our VPC. It's a lot of text for not much interesting things. What really matters is the inter-network access field that allows communication between the different virtual networks, and then a node selector that basically restricts this specific VPC to nodes that are managed by for a specific tenant. Then after the VPC, we have a virtual network, and this virtual network, you can see here, like we define the IPAM around this, like the subnet to use, whether it is DHCP, and then whether it's externally routed, meaning that there is connectivity to the outside world, and in this case, maybe like whether masquerading the traffic is required or not. And again, you can see the same like node selectors saying that this specific network applies only to a specific set of nodes that are given to a specific tenant. And the last CR that matters here is the interface CR. What really matters is only like the part in the spec field, the most inner spec field that defines like, okay, we are working here with a PF. Well, it could be a VF, of course, and we have the PF ID 0 or 1, depending on which interface you're using, and the virtual network that this belongs to. So in this setup, we have basically two DPUs that you can see here as Kubernetes nodes on the left. And on the right, you have the hosts. So you have the worker 1 and worker 2 are the two hosts. And then there you can see the interface ENP204 S0, F0, and P0. That's the interface, the DPU interface. It has an IP address. And you can basically see that there's no other setup there required, like really just giving an IP address to the interface. So at first, we are trying to ping between the two. No traffic is flowing because those nodes have not been allocated to a tenant. And then we are allocating the node to the tenant using a label. And once we have done the labeling of the two nodes, at that point, like both nodes belong to the same tenant, and then the traffic starts flowing because we have actually under the hood configured OVN to allow the traffic, basically by putting the two on the same. Well, this is a layer 2 topology, so it's on the same logical switch. So ping is working. So we're going to do a bit of performance testing to see what we achieve with this. So we are using here IB write bandwidth because this is mostly done for AI workloads. So it's really rocky traffic that matters for us. So we have 8 QPs, like basically connections, and we are basically getting 191 gigabit per second with the encapsulation. It's on Bluefield 3, so there's 2 times 200 gigabit per second, but this setup was done without ECMP, so like we are using only one link, so only 200 gigabit per second are available. And then we are just like testing like what happens when you remove like or deallocate one of the tenants, right? Or one of the hosts from the tenant, sorry. So we remove the label, and then you can see that the traffic right away stops working because that host was removed from the logical switch. And then as soon as we label it again, then of course it re-enables the traffic and everything is flowing again. Okay, so that's it for the demo. Okay. Yeah, so as you could see in this in the demo, right? Like we did a IP write bandwidth test, so node-to-node rocky performance. There was one switch in between the two DPUs. They were connected with 200 gigabit per second links, and we didn't use ECMP on the first test, but then we did another test later with ECMP based on our internal OVS-based router, HBN. And without ECMP, we were getting 191.9 gigabit per second. And with ECMP, we were getting like 383 gigabit per second. This is a bit lower than what we achieved on some other setups. Like when we had like optimized setup with OVN Kubernetes, we were able to go like more like over 390 gigabit per second. But the test setup, the dev setup that we had here in the video was not optimized for performance. So that's why we only get like 191 gigabit per second on the single link. Okay, so here are like the same CRDs that were in the video, but a bit like cleaner and like so that we can specifically focus on it. So we basically implemented this VPC wrapper, API wrapper, let's say, using a concept of isolation classes it's very much similar to like the storage classes that we have in Kubernetes. Here it's just to allow using maybe different OVN backends, right? Like basically one backend is here one isolation class. And then in the virtual network, we have different type of topologies that are supported. Not all yet implemented, but that's the goal, at least in the future. So we have layer 2 or layer 3, and we will need to go specifically with layer 3 for scalability. But in the case of, in either case, there's some shared features like the connection to external world and whether we masquerade the traffic or not. And then the DPU service interface is basically a description of an interface that exists on the DPU, but across all DPUs in the cluster. So there is also a concept of node selectors to say like, okay, specifically targeting some some interfaces on some DPUs, and then you of course precise like which one and to which virtual network they belong. So from here on, this is really just the beginning of the work that we are doing with this OVN integration on the DPU. The core things that we want to bring in are listed here. So first, it's a like IC integration to be able to scale the whole setup. Our target number would be like around like 32K in a far future. But one of the most critical points right now is that in this case, the host can use the PFs or the VFs or whatever, right? But there is no vSwitch on the host. So it means that it cannot use SRIOV or anything like this. It's just like a host device for in case the host is running Kubernetes. So we want to change this. And we want to basically be able to run 2 OVN stack side by side on the DPU. One to provide the isolation, like the Baremetal isolation for the PF extra, and one to provide the offloaded CNI feature for the workloads. Then a couple of things that were discussed in this conference, actually, the BGP VPN integration to be able to extend our overlays to different to different virtual networks, different VPCs, anywhere else where the customer requires it. And then like we want also to use OVN BGP instead of having to use an external router to do ECMP, for example. Then there was a talk about like using OVN to do SFC. That would be a nice feature to add. And then also providing the switch to the host. And in this case, we could have actually nested OVNs, right? Like one OVN whose traffic would be encapsulated in another OVN setup. But this is a much more long-term goal. And the last point is to strengthen the multi-tenancy API that we currently have, because right now, like it's a Kubernetes API that is only like managed by an admin, so you need your CMS to provide this self-service APIs. So we are like considering like how to bring this with a more user-friendly API. And yeah, this is about it. If there's any questions on this.
Thanks a lot. With it being used to also separate tenants, so as in if the host is owned by some untrusted third party because you give it out to your customers, how do you prevent him from accessing the DPU in some kind of way?
Yeah, so it's a feature of the DPU actually that we call zero trust. So it basically allows you to completely cut all communication from the host to the DPU. This means that the host is not able, for example, to flash the firmware or like to do any modifications to the DPU. The feature that we had called RSHIM that was allowing direct traffic from the host to the DPU, that is also completely out of the picture. So we have a bunch of mechanism that comes from the DPU itself that allow to prevent this specific communication and isolate the DPU as a separate unit from the host.
Thanks a lot.
You have here on the slides the nested OVNs bullet point. Do I understand correctly that then you have double encapsulation?
Yeah, that would be the case. But as said, this is a very far feature because we don't have that yet in the NICs.
All right.
So it's maybe let's say we want that on the roadmap.
So it's not yet on the roadmap, but you want to add it, or
Yeah, once we have the hardware and firmware for this.
We have a comment online from Alex, not a question, but a note. When doing bare metal, cloud network isolation is one of the least concerning things, mostly because OVS is working on DPU. Isolating NV links, IB networks, other possible side channels, and protecting GPUs, BIOS, CPUs from malicious upgrades are much more of a headache. And provisioning, managing DPUs inside already existing infrastructure inside of a data center might be a challenge.
There are no other questions. Let's thank our speaker, Mile, again.